Okay. All right. Okay. So thank you so much, everyone. I'm gonna start the lecture now. Okay. Um, yeah, welcome everyone to FIT 5136 Software Engineering. This is the unit as the core unit for the Master of IT and other degrees as well, like my Master of Cybersecurity. And I hope that everyone will enjoy, whatever I teach about the software engineering today and throughout the semester as well. So first of all, before I start, I just want to say thank you for your attention, and I really am so glad to see everyone here in the online lecture as well. Right now, we have roughly 82 students, and I hope that we can grow more over the next few weeks as well. Okay, so today is the maybe I'll just first introduce myself. My name is Kla Pantitam Thawan. So I am an associate professor in software engineering at Monash University. I also have industry experience working at Atlassian, which is a top tech company who developed Jira, Bitbucket. If you have used Loom before, that's a video or recording software. Yeah, so that kind of software over the past few years. And then right now we have an ongoing research collaboration with them as well. So if you have used Trello with as part of the unit, so basically it is the product behind this company as well, Atlassian. Okay. All right. So my name is Clara, as I already mentioned. So today I'm gonna talk about the introduction to software engineering. But before I start, I just want to give the high-level overview as well, how the unit is structured, that kind of thing. All right. Again, my name, I'm the chief examiner. I just want to introduce myself. I'm the chief examiner, also the lecturer for the Clayton campus as well. Because this unit is run in parallel with the Suzhou campus. So we have Dr. Najam Nasar. He will be the Suzhou lecturer. And for the Clayton campus, for many of you, we have, a list of the tutors here. We have Max as the head tutor. We have Chiming Deng. We have Anthony. Uh, we have Aaron Cheng, Aaron Guo, Meet Chama, Neda Wang. Okay. So these will be the tutors, and I'm pretty sure that some of you have already met them. Okay, in the apply sessions on Monday and also Tuesday as well. All right. So um, before you learn, okay, just want to make sure that we are on the same page and we are aligned, okay? So the goal of this unit by the end of the semester, okay, after you have complete this unit, these are the unit learning outcome, all right? The first thing is that I expect everyone to be able to describe or differentiate different phase of the software development lifecycle. For example, what is the requirement gathering, design, implementation, testing, deployment, and the maintenance, that kind of thing. And at the same time, I expect everyone, okay, to understand how to design the software architecture, how to design the class diagram, design the complex software system, that kind of thing, based on a given requirement, using some UML diagrams or some notations, okay, which is the standard language that we use nowadays. And because when you develop a piece of the software system, we want to make sure that it lasts like, for a few years. It's not like, yeah, develop today, tomorrow it's gone. We just throw into the bin. Not like that, okay? It's a waste of money. So we want to make sure that the software is maintainable. People or your friends or your colleagues can collaboratively work with your prototype as well. So I think the most important part is how to design the software system that is aligned with the OOP structure, that kind of thing, OOP principles. All right. And when we develop the software system, we want to make sure whether the piece of the software that we develop is actually aligned with the given requirements or not, right? So we're gonna teach you about how can we implement the software testing strategies, different ways to design the test cases, how to measure whether the software that we develop is actually completed or not, okay? And actually functionally correct as well. All right. And because software engineering is not a single person work, we need to work as a team. And then we want everyone to effectively work and communicate with your team members as well to work on the projects. All right. And at the same time, we are human. Okay. We need to be ethical. So we want to make sure that everyone can identify the ethical issues in the software engineering, including the IP, privacy, security, and adhere to the professional standard and practices as well. Okay. So that's the high level of the unit learning outcome. Okay. Um, because just want to let everyone know that based on the high level, we already designed the structures of the unit to follow the Agile Scrum project management, this framework, the Scrum framework. Okay. So that means within your team, either 3, 4, or 5 students whatsoever, you can take the role, whether one can be like product owner, one could be like engineers, one could be a tester whatsoever, right? And then you can rotate whatsoever. But we try to align the lecture contents to follow the Agile Scrum as much as possible, and which actually follow the standard software development lifecycle processes, right? And that means normally student will start from elicit the requirement, okay? Design the software system, so and then implement something, and then you can go through the iteration, test the software, refine the requirement and things like that, and then deliver the piece of software as a project by the end of the semester, week 12. Okay. So in general, right, we have so this is how we structure the materials or the lecture, okay, on the second column here, week by week. Okay, so for the first week, we will talk about introduction to software engineering, what is a software development lifecycle, that kind of thing. And then once you understand the high level software development process, then we'll start talking about how should we elicit the requirement, how can we categorize or analyze the requirement and things like that, what would be the functional or the non-functional requirements, we'll go to detail, right? And then because we develop software as a team, we need to understand how to manage the project. So in this unit, we're gonna teach you about agile project management, okay, and things like that. And then you will learn about software design and modeling, how to draw the class diagram, sequence diagram, and things like that, or the use case diagram. Okay, and once you and then we will teach you about the high level principles of the software quality and testing. What is the software quality? What is the testing? What should we consider? How to develop the unit testing? Are there any other techniques to develop the test cases to make sure that we can verify or validate the software, right? That we actually implement. And then definitely, once you test the software, you want to make sure that the code is being reviewed by another friend or your colleague as well. So we're going to talk about the code review process, all right? And then CI, CD, and definitely wrap up by the software engineering ethics, okay? In terms of the assessment, which is really important, we have two types of the assessment, the team, okay, and the individual, all right. So the team, the first submission is on the Monday, week 5, roughly, okay, because just the day before the census date, all right. So that's a team base. Basically, we're gonna give everyone a high level software requirement, okay, and then student need to elicit the requirement from your tutors, okay, and then that's the process to gather the requirement. Once you collect the requirement, then you analyze whether it is functional, what is non-functional, how to write the user story and things like that. The detail will be provided later. So that part is belong to the assessment one. All right. Once you submit the complete the assessment one in week 5, and then you start doing the software design and modeling. How should you define the class diagram and things like that? And then it will be part of the assessment tool, A2 here, which I believe the deadline should be week 7, okay? Which day of the week, we will let you know later, all right? And then once you submit the second assessment as a team, anyway, You will work and then you will start the actual agile process. Okay, so we will break down the development process into 4 sprints. Okay, the first sprint will be so basically you need to like think about how do you manage the project, that kind of thing, using the Trello and blah blah blah. Okay, so that will be part of the sprint 1. Sprint 2, we check your progress and things like that. Sprint 3, you deliver something, and then sprint 4, you will give a presentation about what is your project about. Okay, so that's the team-based part. Okay, the project-based. But at the same time, when we have the team assignment, we don't know whether it is actually, like, how can I say, we need to balance between the team assessment and the individual assessment as well. So in terms of the individual assessment, it will be in the EDSEM only. We will give the requirement. Student need to implement the test, the software based on the given requirement. Okay, the functionality, we already will give some scaffold template of the code to you. Okay, and then student need to implement the code, Python code based on the given requirement, write the test cases to achieve 100% code coverage. And then we will do the automate marking later on to make sure or verify whether whatever each of you implement is actually functionally correct or not, or based on our given requirement or not. Okay, so that's the individual part. I will let you know later how does how to work on that assessment. But over the semester, you will start practicing the unit testing, that kind of thing. Probably from week 8, 9, 10, something. Okay, I will let you know later as well. So we will have lots of exercise for everyone to practice, and this is a mandatory exercise. No one can work on the A4 assessment without completing this exercise. Okay, and there will be only 14. No, sorry, 9, maybe 9. Okay, 9 exercise that everyone have to complete. Okay, just want to let everyone know in advance. All right. Okay, cool. That's the high-level structures of the unit. What else do I miss? For the sprint, okay. So we try to mimic the agile process as much as possible. That means the tutors will act as a scrum master, okay, and try to go through the table and check the progress, whether you actually complete the task based on the given instructions or not. And that means by the end of the sprint 1, okay, by the end of that week, we highly encourage, not highly encourage, it is mandatory, okay? It is in-class evaluation. So make sure everyone actually attend the week 7, week 9, week 11, and the week 12, okay? So week 12, that's a presentation, unless you have like, injury crazy that you need hospital, please, everyone must attend the apply sessions, all right? Okay, that's a high-level structures of the unit. I got another question. What is the difference between in-class evaluation and the presentation? Okay, so the in-class evaluation is like a regular review. Okay, it's like sprint checkup. Okay, that means the tutor will just walk around the table, the groups, okay, and see like how do you perform, what you have done, and things like that. So we continuously mark your project, okay, your project. Not the reason that we do that is that software development project should not be something that is the last sprint before the final presentation. No, it's about the continuous development over time, over a period of time, right? So that means we expect that from week 7, student already work as a team, develop something, manage the project, assign the task, who is responsible on what, that kind of thing. All right. And then the final presentation, which is on the week 12, this is easy. Just presentation, what you have done. That's it. Okay. Any other questions? Feel free to ask. Will the presentation be only to the tutors or in front of the class? Oh, so it will be in front of the class, but the application class. So it's not for 200 students here, not in the lecture. And we already allocate. Oh, one more thing for the week 12. Just want to let you know that it is 3 hours. You can check the your what is that the schedule in the allocate plus whatsoever. Okay, so for the week 12 it will be 3 hours, but for the other week the apply session your own, okay, will be only 2 hours. Okay, any other questions, everyone? Thank you. Fantastic. Okay. Oh, I just realized I talked to the direct message. Okay. Anyway, all right. And for the lecture each week, okay, we will run the lecture online only, nothing on campus. The on-campus activities will be the applications only. All right. And I will run the lecture on Zoom, and I hope to see everyone here. I'm so glad. Like today we have like 123. Make sure that we keep 123 students until the end of the semester. Don't drop it, okay? And then yeah, the lecture will last roughly 2 hours, okay? For some week, I will provide some pre-lecture or post-lecture reading. It really depends on the week, but I highly value everyone's time, so I want to make sure that I include everything within the lecture 2 hours as much as possible. And for the lecture, once I finish the lecture, the recording will be provided and upload to the EdSTEM as well. Okay, so yeah, give me roughly 24 to 48 hours. It should be roughly around that. Then you can watch it later as well. Okay, but the good thing when you attend the online lecture, my point is that I try to introduce the quiz as much as possible. Keep in mind the purpose of the quiz is not to mark at all, okay? Or we didn't collect the mark as part of the quiz, but the goal of the quiz is to make sure that students actually follow the concepts of the lecture or not. So it's like a continuous checkpoint of your learning, okay? That means if you provide like a wrong answer or whatsoever, I'll try to correct them or explain immediately within the lecture, okay, as much as possible. All right, good. For the application, yeah, some of you have already attend. It is 2 hours. We run every week. You have to participate to the applications every week, and attendance is very important because it involves the team project, team submission, and things like that. So roughly, we expect everyone to contribute to this unit no more than 12 hours, unless you have higher motivation, then you can go further, okay? Go max. No worries at all, okay? uh, as part of this is academic integrity, okay? Similar to other units as well, cheating and plagiarism should be is not should be avoided, okay? Not should be. I should say must be avoided as so we do not allow anyone to plagiarize or cheat or that kind of thing within the unit, all right? And we gonna follow the academic Monash academic integrity policy. So you can check that, all right? But due to the academic misconduct policy, what I understand is that you may receive a 0 mark for the assessment, you may receive a 0 mark for the unit, or you may be suspended for the whole degree as well, or you will be excluded from the university, right? But at least what I can tell is that over the past few years, some of the students already do some plagiarism, and what will happen is that they already have record in the system, in the university system, right? That some of the students have been colluded. I mean, the submissions have been colluded whatsoever. And then later on, when the company do the background check with the university, that kind of record will show or appear in your CV and transcript as well. What I can recommend, okay, do your best. The unit is not too difficult as it should be. So yeah, don't cheat. Be honest to yourself. Yeah, to be honest. Yeah. All right. In terms of the AI use for this unit, right? Personally, we allow, okay, we actually encourage everyone to use it. Yeah. But you should be aware that such kind of AI coding tools, right? They are not perfectly correct, or despite they are quite advanced nowadays. But because we have what is that the code submission, you should think that there there might be some cases that whatever you submit may be similar to the other student, okay? Because the code that you wrote, okay, may not be originally from yourself, right? Okay, so there is a high chance there, yeah. And internally we run the lots of plagiarism checker as well, not just only the PDF file, but also the code that you submit as well. And we have seen this kind of high similarity over the past few years. Yeah, so your life is on your own, okay? Take your own risk. Yeah, any other questions about the ChatGPT, AI, and plagiarism, academic misconduct? Any other questions? Will we using the same Zoom link for the lecture each week? Yes, correct. Yeah, just for your own convenience. We use the same link every week. Yep. Okay. In terms of the programming languages used in the unit, we normally allow the student to use either Java or Python. That's the most popular programming languages. For the but I mean this one, okay? Either Java or Python is for the team base. That means for the team based assessment, you can discuss among the teams like whether you want to prefer using Java or Python. But for the assessment for it will be Python only. Okay, we will not prepare for the Java. Okay, another question: are we allowed to use GPT to help us debug, not write our code? Yeah. Honestly, I would encourage it, right? And then let us know like whether it works or not. Okay. Yeah. Yep, that's right. Any other questions? Okay. Yep. Okay. In terms, yes, go ahead, Jeremy. Okay, you need to unmute. Yep.
Just with regards to programming languages, are we able to use languages like C Sharp?
Uh Likely no. Okay.
Okay.
Unfortunately, yeah. So we prefer either Java or Python. The reason is that this is the tutor marking
Yeah. No, that
capacity
makes
as well.
sense.
We don't have capacity to mark like different programming languages, that kind of thing. Yeah, that's right.
Yeah, that makes sense.
Yeah,
I
thank you.
just wanted to confirm that question.
Right. Okay. Thank you. Really appreciate. Yeah. Okay. Good. All right. In terms of the development tools, right? This is just a general. We're gonna use the Trello to manage the project. Definitely, we will use the GitLab for the collaborative coding. That means student may need to write the pull request, do the code review, that kind of thing. Commit, Git branch, whatsoever. Okay, we will provide create the GitLab repository for you. In terms of the software design and modeling part, you may use the Lucidchart to draw the diagram and things like that. Okay, but other than that, right, you can use the VS Code to write the code whatsoever. Okay, whatever you prefer. Yeah. All right. Um, most of the learning resources will be available on the EdStem. Okay, if you go to the EdStem, click the lesson, you will see everything there. If you want to see anything in the Moodle, there's nothing there. Okay, so you don't need to even try to find anything in Moodle. The Moodle we will use only for the submission only, especially for the assessment 1, 2, 3. Okay, and for the assessment 4, we will use the EdStem. All right, that's all. Okay, another question. Are we gonna set Trello up in the apply session or do we do it individually? You can set up during the apply session. This is part of the teamwork. That means, what is that? You need to invite your teams, your friends, okay, to your Trello board as well. Yeah. So that means it's a team-based assessment. We consider only one Trello board per team. Okay. We don't need 5 Trello board. All right. Yeah. Okay. Good. Okay. And throughout the lecture, I try to make the lecture more interactive as much as possible. So let's start with the first poll everywhere question. All right. Where are we? Let me think. Okay, everyone just go to the polev.com/fit5136. I want to see if everyone can, access or not. Yes or no? Maybe can you say something in the Zoom chat? Okay. Yeah. Can anyone access or not? Just want to double check. Yes. Okay, cool. Easy. Yeah. The first question, all right? Don't think so hard. This is not mark at all. I just want to know your experience about software engineering, like whether you are like new to the software engineering world or whether you have done something over the past few years as part of the undergrad or you build something, publish on GitHub. No, I mean, did you see the poll EV? Can you answer that? Can you answer? You can click? Oh dear. 1 second. One second. That's why. Okay. What about now? Can anyone click? Activate. Present. Is show weapon has been done. No, no one can click it. Okay. What about this? Yeah, okay. Try again. Here we go. Huh. Okay. 39, 40 responses. Thank you. Okay, so we have 127. Let's aim for roughly 100 response. Okay. Be quick. Life is short. We need to be quick. All right. Okay. Let's see the response in general. Okay. So roughly 50%, okay, 42% of the student. No. Okay. I need to lock it. Yeah. Okay. So how many response that we get? The what is that? 89. Okay. We have 89. So most of the student either have no prior experience at all or complete something in the past, or 80% of the students have built some small projects already, or where the minority of the students have some industry experience contribute to the open source software projects. But wow, 6%, okay, build system that serve millions of users. Can you introduce yourself? You are the boss here. Do you want to introduce yourself or not? Yes? Okay. So, yeah.
Yeah, I've built several systems that have served millions.
Okay. Sorry to put you on the spot. Okay. Jeremy, maybe can you introduce yourself and what kind of projects or system that you have been working on?
Hi,
Yeah.
so I'm Jeremy. I'm currently a software engineer at a technology company in Melbourne. You can look at my LinkedIn to find out where. And basically, I've built data pipelines that serve the automotive industry, so one of the big marketplaces in Australia. Basically, I'm in charge of getting the data from our researchers who create reference data and then transforming that into formats that can be used by many different companies, both internally at my company as well as externally. As well as that, we build some smaller projects that are basically, how would I say, they're add-ons and like augmenting the data for different purposes.
Wow. Okay. Yeah. Thank you. Thank you so much. Very nice to meet you. Hopefully we can share something in the future as well. Yep. Very good. Yeah. But anyway, most of the students haven't or have little experience about software engineering. That's why you are here. Okay. Yep. Thank you. So I'm gonna continue the lecture. All right. Yeah, I'm gonna start now. What is software engineering, right? The motivation here is that right now, we are in the age of the digital world. AI is booming, and many industry they try to undergo the digital transformation. They try to adopt like the next generation technologies, AI, machine learning, augmented reality, virtual reality, IoT, cloud services, whatsoever, right? And surprisingly, no one can actually access this kind of system without the software engineers at all. That's why the roles of the software engineers are so important nowadays, even the age of the AI. Think about the ChatGPT. You think that ChatGPT is really AI, right? But personally, I feel that the AI model is just only the core component there. But how can we build the whole system, ChatGPT, to serve like billions of users to use nowadays? This is really the software engineering work, okay? And how can we deploy, scale the system up to million and things like that, okay? And yeah, the roles of the software engineers is really important for many sectors, okay? Including online banking, telemedicine, e-commerce platform. You have used all of the software system, no wonder. And this is an example of the software system, just in case you don't know what exactly is a software system, okay? Like in the healthcare sector, okay? Normally they use like electronic health record system, or you use some mobile application to book, to see the doctor, that kind of thing. That's a software in the healthcare system. Or in the finance sector, right? You can use like what is that, the CBA application, the bank application to withdraw, deposit the money, transfer the money, and things like that. So in short, right, software is actually everywhere. It goes to every sector that we use every day. Start from the moment that you actually wake up. Like if you have alarm clock in your iPhone, there's another application in the iPhone as well, right? But the key question here, why do we need to learn about software engineering, is that the key question is how can we develop high quality software system that meet the needs and requirements of users, stakeholders, and the organizations, and importantly, at the lowest cost. Okay, that's why software development or the programming is totally different from the software engineering. Software engineering, we try to apply the engineering disciplines, optimize the process and everything to make sure that the development cost is actually at the lowest one, right? Okay, so that's a key question. But the question is that who actually coined the term software engineering, all right? So this term actually was coined in 1963 by Margaret Hamilton. She's a computer scientist and system engineer for the NASA Apollo missions, right? So she worked on the project at NASA, and then one day she coined the term software engineer because she felt that the work that she and her team were doing was just as important as just much of the engineering work that for the Apollo spacecraft, right? So later on, she coined this term, and then she advised the team that, hey, look, we need to apply the engineering disciplines into the computer programming or software development and things like that. Okay, so that's why it becomes a software engineering discipline since then, 1963. So roughly, what is that? 2026 minus the 1963, 60, 70 years, okay, roughly. Okay, but the key question from many of you is that hey, look, what exactly is the difference between the computer science and the software engineering, right? So it is a closely related discipline. And however, computer science actually focus more on the theory, the fundamentals, data structure, algorithms. How can we design the algorithms that find the shortest path between Clayton and let's say Melbourne CBD? That kind of thing. That's really the algorithm. Okay. But when do we need software engineering? That's the moment we want to build the Google Maps. Okay. How can we display the Google Maps? How can we build the UX, UI, or store the data, that kind of thing, to make sure that end users can actually use the Google Maps easily, right? You have an algorithm. No one will access the shortcut path algorithm on the command line or the terminal, right? In real world, we need to access through the website or the mobile apps. And that's why we need the software engineering. And one key part of that is to, talk to the end users. Okay, what do you need? What do you do? And that's how do you develop the software. What is that? Develop the software that meet the needs or the requirements of the user. That's the requirement engineering part. Okay. Okay. Yep. However, we develop software, we have NASA, we have whatsoever, but in real world, in reality, bugs are, software defects or software bugs are actually everywhere, right? And most of the time, software engineers put lots of effort or prioritize the software development and ship in production, okay, without actually have time to test. And that's why some terms actually emerge. For example, yeah, within my team, we're gonna test in production, okay? So we don't test internally within the team, but whatever we develop, the CEO already asked, okay, we need to ship this feature now. All right, tomorrow, let's go ship it, right? And then what happened, okay? See, like this is an example. Mikey, Melbourne Metro Smart Card ticket system, okay? They actually took 7 years more than the plan, and they spent 55% more than the budget, okay? And what is the problem exactly? It's about unclear divisions of the responsibility, lack of expertise and knowledge in the field, vague system specification, scope creep, as well as the poor working relationship between the contractor and the transport authority, right? So at the time, first, they cannot deliver the system on time. It took 7 years more than the plan. And then the Mikey system still has glitch, right? And yeah, so that's the reality, right? And another example, CBA outage, okay? If you look at this one, it happens more and more often in recent years as well. Think about the CrowdStrike over the past few years, okay? But you need to think about the consequence. When the CBA system is outage, then what happened? We cannot even log into the net bank. Oh, we want to purchase something, but no, we cannot make the money transfer. We cannot withdraw the money through the ATM. The POS machine is offline. You cannot buy stuff from the Woolworth, Coles, and everything. And then it actually cost $7.5 million each time it failed, right? So there are lots of issues behind the software engineering failures, right? It's not just only the software development itself, but could be part of the project management, the team, the culture, infrastructure, network, and everything. Okay, that's why we need to learn how to engineer the software system at the highest quality, but also at the lowest cost as well, right? We cannot spend, like a million years to develop just one piece of the software system. No, we cannot do that. That's not the engineering discipline. Okay, when we already know that software is failed, okay, in many cases, but probably the next question that you may ask is that what is the attributes of the good software system, right? So this is like just a high general definitions of the quality attribute for the software system. We will talk about that in detail, okay? But in general, it could be, easy to maintain. Software should be written in such a way that it can evolve to meet the changing needs of the client. This actually happens in the real world companies, right? things change every 3 months, things change every quarter. One day when the technology is emerged, okay, let's ship it. We're gonna need something. And then if we didn't decide the architecture behind of the software system in advance that are flexible to change or adapt to the new requirement, then it may take like forever, okay? And then we cannot compete with the market, right? That's why software maintenance is really important, okay? And when we develop the ChatGPT, we don't want to, that's an example. We don't want to, ship it and then, yeah, no one actually maintain, right? Look at the Windows, we have Windows more than 20 years ago. We still have Windows today. That's how the company run the business, okay? All right. Good software system, okay, should be dependable and highly secure as well. So it should not cause any physical or economic damage in the events of system failure, right? Malicious users should not be able to access or damage the system. Wow, the security is so important every day for every company. If you work in real companies, there will be the security team and they receive the incident every seconds, right? Someone try to hack the system, hack the whatsoever. Think about, yeah, Microsoft Word whatsoever. Someone really try to crash it. I don't know why, all right? Yeah. Efficiency, okay? The software should not waste the system resources or memory processors cycle on something. Let's say you have a calculator app. If it takes 5 hours just to do 1 + 1, that's really a poor design software, okay, at all, okay? And yeah, but when we develop the software system, you want to make sure that it is actually acceptable by the end users, right? Because they are our target, right? We design and develop software for the end user, so they must accept it. That's why later on we're gonna talk about the user acceptance testing and things like that. Yep. But in this lecture, okay, that actually part of the software quality whatsoever. We're gonna talk about in more details in week 7 as well. But what exactly is the software engineering? The key components of the good software engineering team is really about first people. How can we develop software without people? That's impossible, right? And the people here we are talking about the software development team and who are actually the client, okay? And who are actually the end users. We are just software developers, software engineers. We want to design, develop the software that meet the client needs, right? So that's the people or the stakeholder as part of the software engineering team. And once we already have a team, the people, the next step is what should be the process that the team is going to use to develop the software system, right? And it really depends on the scenarios or the context. For example, let's say if I need to develop a software system for the mission critical, let's say if I put today's situation in the context, let's say, yeah, I'm gonna develop the software for the defense, the army, right? Let's say spacecraft, okay, spacecraft, the aircraft, that kind of thing. So every calculations of the aircraft should be accurate, right? And it cannot miss. Otherwise, the aeroplane just fall down, okay? Hit the ground, and then boom, okay? It's not safe at all. That's why for such kind of a mission critical projects, we need to make sure that the requirement is solid and in advance. So waterfall might be more suitable, okay? On the other hand, let's say, yeah, I want to build a startup. I want to develop some software system. Yeah, but honestly, I have no idea, right? Then agile might be more feasible or more suitable here in this context. Okay, so it really depends on the process. I will talk more later as well. What is the agile and the waterfall, and also technologies as well. When you develop the software system, you need to design whether you're gonna deploy locally, deploy on-prem, on the cloud, using whatsoever Google Cloud. Products or Amazon Web Service whatsoever. Or yeah, which object-oriented design, what software design, what models, what framework that you are going to use, what programming languages, what would be the testing method and the tools and things like that. So at the beginning, when you form the team, you should have some how can I say, define the policy, or the standard in advance so that everyone within the team can follow. Then everyone is aligned, right? Then there will be no miscommunication at all. Okay. So software engineering is really about the human. Okay. We as a developers, we need to develop something, but as a team, we need to communicate with another software engineers or your friends as well. That's really human. And yeah, communication is really important here. All right. So to develop the software system, right? Okay, let me bring the how can I say? So today, for this one, we're gonna talk about the software process. What exactly is a software process? It is a structured set of the activities required to develop a software system. And we can break down the tasks into the smaller step here whatsoever. And in general, we're gonna start from the requirement, what will be the specification of the software system that we are going to develop, right? And then once we have the high-level requirements, then we can design the system, and then we can implement it. Why do we need to design? So that we can have a shared understanding of, for example, the class diagram, okay? Let's say if you want to implement a login system, you need to design, okay, with the class login, what would be the data attribute, whether each data attribute will take the input as a string, as an integer, or whatsoever, right? That's a part of the software design. Once you design the software system, then you need to verify whether whatever you actually implement is correct or not, and validate as well, and then maintenance, okay? Okay, but whatsoever, no matter what, no matter what process that you want to use, in real world, there are only two factors that the CEO care about: the effort and the cost, okay? So, and the fact here is that bad software works only for one time, okay? And it cannot be reused at all. It cannot be recycled. It cannot be evolved. Tomorrow I want another feature, then we cannot even extend it, right? That's another an examples of the bad software. However, if you think about the good software, it evolves over time, right? Think about the Windows. 20 years we have Windows, nowadays we also have Windows, okay? And it is become part of the bigger system, easier to integrate into another system. That's why we need to design the software in a modular way. We will talk about the software design patterns later on as well, how to design the method, the job, no, sorry, the main, the single responsibilities of the function method whatsoever, okay? Yeah, and if you want to develop the software system, in fact, right, the majority of the cost, okay, actually goes into changing the software after it has gone into use, okay? So that means you have a team, you develop it, the real cost comes into the maintenance, okay? Because you develop, what happens is that you develop, let's say you spend 3 months to develop the software. What about another 3 years left, right? The next 3 years, you actually need to maintain, and then it costs a lot. And surprisingly, software maintenance actually costs more than the software development, right? Let's say someone, okay, at the beginning, right, design the code or the architecture like this. Later on, it doesn't work at all. Maybe someone need to redo the work, right? So that actually costs a lot, and we need to spend lots of time on rework things rather than ship it, right? Okay. Fixing a fault is easier and cheaper if earlier in the life cycle. Okay, this is so important. That's why with this sentence, it means that we try to shift the testing or validation process into the early phase of the software development as much as possible, right? So that means once you find back from the requirement phase, let's say you elicit the requirement, you already thought that, okay, what should be the acceptance criteria? How should you develop the test cases and things like that? And then you found that, yeah, something doesn't work here. Okay, let's say you want to develop, let's say, a division, division in the calculator app. Okay, you may thought that, yeah, we cannot divide something by 0. How should we handle this case? If you discuss with the client from the beginning, oh, Yeah, don't throw the stack trace on the GUI. Okay, we need some proper warning message to the end user that yeah, that number, that equation doesn't work at all. We cannot divide something by zero. Then uh, once the more you can handle this kind of cases, then the fault will be less as well. Yeah. Okay. And again, software costs more to maintain than it is to develop, especially for systems that are long-lived. Oh, I just said that. Okay. uh, in short, the software engineering is really about the economic aspect. It's about the cost, it's about the money. To develop the software, we need to spend lots of money. All right. Okay. One question. Just like it is a lot harder and more expensive to redesign your house or fix a water pipe after your family already moved in. Correct. Correct. Yes, you are right. Yeah. Okay. And because that's the high level step or activities of the software development process, right? However, different companies, different teams, they work on different types of the software system, which require different types of the process as well. Okay, that's why nowadays there are different process. Okay, that have been defined. For example, the waterfall, rapid prototype lifecycle, incremental software development. That's by the book, agile methodology, and we cannot run agile on the open source software system as well because the team is everywhere, right? So yeah, that's why right now different software development processes have been defined. Okay, maybe I'll just start with the classic one. Okay, waterfall lifecycle model. It is more plan driven process. It means that you cannot even move on to the next step with if the plan is not carefully designed. Okay, that's why it's called plan driven. That means the first step. Okay, you need to it's called requirement. Okay, requirement engineering. You need to elicit the requirement from the client. Then you start the next step, analysis. Okay, analysis means you want to identify what the product is supposed to do. Okay, so that's the requirement analysis. These are the features. Oh, log in, log out, exchange the token, authentication, whatsoever. Okay, and then you need to design the design the software architecture or model the software. Okay, how the product does it, right? Okay, maybe with this kind of feature, we need the login class diagram. We need the customer class, the login class, and things like that. What would be the method? What would be the data attributes that we're gonna collect and things like that? And then once you implement, then we move on to the implementation phase and maintenance and the retirement. Okay, retirement means like in the past. This is waterfall is more like how can I say? 30 years ago, people used waterfall as part of the, let's say, software house company, right? Like client hire a software house to develop the software system. Once they finish the development, retire means, okay, they deliver to the client and then all done. My life is done, okay? Move on. That is what happening in the past, but nowadays it's not like that. Yeah. Okay. In short, yeah, waterfall lifecycle model is really a plan-driven. All activities must be planned in advance, and it progress. Then the progress is measured against the plan. Okay. For example, once the requirement is finished, done. We will not go back to the requirement at all. We're gonna move on to the analysis phase and things like that. That means the process is so rigid and it doesn't allow any requirement change or welcome the requirement change at all. Okay. Waterfall lifecycle models also requires a concrete planning. Yes, that's what I mentioned. Okay, there's no right or wrong in the process, right? But I think it is really about which process actually fits the context of the team. Yeah. So the way that means when you form a team, you may want to understand what is the context of the software projects that you are going to do, and then you will choose whether you're gonna use the waterfall or the agile and things like that. Okay, This is another example, the example that I already mentioned as well. For large system engineering projects, right, where system is developed and at several sites, the plan-driven natures of waterfall model might help to coordinate the work here. Let's say, I work at the what is that? What is that? Let's say I'm gonna develop like a weather application, okay? Weather forecast application. I need to follow the data standard from the bureau, something, okay? I don't know how to call, but they already collect the statistic, blah, 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 and things like that. So waterfall might be suitable here because we're gonna develop something that is actually, based on some predefined standard or the requirement, okay? But at the same time, the downside of the waterfall is that the moving target problem. When we have a new requirement, we cannot change at all, okay? Yeah, what exactly is a moving target, right? As software is being produced, the requirement change, okay? The reason is that company change, company reorg, the team reorg, okay? Client keeps changing what the software should do. Sometimes at the beginning, the requirement is unclear as well. And later on, when the client understand more about what do they want, and then, they just keep changing. Oh, can we do this? Can we do that? Right? And later on, it becomes a problem, which is called scope creep. Okay, I'm going to talk about that. Scope creep, yeah, later on in the project management week. Okay. So, and the problem is that when you keep changing the requirement, any change made to the software system can potentially cause a regression fault as well. Okay. Yeah. That's why later on, this is by the book, okay? That's why later on they come up with or propose a new software process, which is called waterfall lifecycle model, but with the feedback at all, with the feedback as well, okay? So structure is the same: requirement analysis, design, implementation, post-delivery, maintenance, retirement. But at the same time, for each of the steps, right, they allow the change in the requirement as well. And then they just define this kind of process and use it, okay? Yeah, but there are some problems with the written specification, right? Sometimes at the end of each phase, technical documentation will be produced, yes, like UML diagrams and things like that. However, these are so difficult for the client to understand, all right? That's why, like for example, right? Like think about waterfall, they develop the requirement specification document, and it's like 100 pages. First question, how the client will understand that? They actually have no idea. How does it look like? Let's say if I want to develop like let's say Kohl's checkout system at the what is that? Like when you buy things from Kohl's, right? Okay, the software should have the barcode scanner. It should calculate the price based on the item. It should apply the flyby membership card. It should blah, 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 accept the payment, blah, blah, blah. But that's the high level requirements written in the text that the client actually have no idea how does it look like. And no one understand, right? And that's one of the cause of the software project failure as well. That's why later on we're gonna talk about the rapid prototype software development. Okay, that's a teaser. Okay, let's go back to this one. So that's why software is really different from the traditional engineering, right? Think about you build a house. That's a traditional engineering, civil. When you build a house, you already define, we need 4 bedrooms, 2 bathrooms, we need a kitchen, living, 2 garage here. All done, okay? The spec is there, the drawing is there, the contractor come, build the frame and everything. Done, deliver, get the money. However, in software engineering, it's really abstract. When we write the requirement, everything is so abstract. Yeah, we need a payment system that actually accept credit card, Kohl's Pay, and flyby credit. I'm like, yes, okay, but what else, right? There are lots of details in there. So most of the time when we develop this kind of software system, the feature space is actually infinite, right? Infinite, it is hard to predict what happened tomorrow. Maybe they're gonna say, the client say, yeah, we need another feature. Oh, damn, okay. Then we need to like it will impact the team culture and the workflow and the effort as well. Okay, so and with the waterfall, right? Another challenge is really about the detailed documentation. Before we move on to the next phase, we need to finish the requirement, write the requirement specification in a super detail that we actually don't know how does it look like in real world. And that's the downside of the waterfall. That's why nowadays people tend to use the rapid prototyping. Okay. And what it means that a prototype is actually an initial version of a system used to demonstrate the concept and try out design options, right? A prototype can be used in the requirement engineering phase as well. It can be used as part of the design process to develop the UI design, or we can use as part of the software testing, user acceptance testing as well. So the rapid prototyping, it is actually a working model that is functionally equivalent to a subset of the product. And nowadays, surprisingly, we have lots of tools available like Canva. You can draw like a digital prototype. Like back to 10 years ago, you need to develop the wireframe, right? And just like a square box where a wireframe of the mobile application and things like that. But nowadays, everything looks so real. You have images, you can decide the tone, the color scheme, or where the navigation bar should be, that kind of thing. So once you have the prototype here and present to the client, they tend to understand more about how the final deliverables look like. Okay, and it will reduce the chance of the misunderstanding in the requirement phase. Okay, and things like that. Okay, another question, another comment in the Zoom chat. What are the difference between software engineers and architecture engineer? It seems that there are many overlapping parts in the implementation process of the projects they are working on. Um, I'm not, I think, let me rephrase the question. I think nowadays there are two main roles, okay? Software engineers and the solution architect, okay? Software engineers, you write the code, develop the code, build the system whatsoever. But at the same time, right now, the technology and the component is actually deployed in the cloud. And that means everything and you need the solution architect to actually design the high level component of the software system. Okay. So that means software architect, they tend to work more in a higher level, but the software engineer, they focus more on the code. Okay. Think about, let's say you want to develop an API services, and then there are lots of components in there, right? For example, API, how can I say, what would be the right example? Let's say you want to develop the Kohl's shopping, okay? Kohl mobile app, okay, for the online shopping. Login authentication could be one component, but let's say if you want an authentication with a Google account with the something else, or you want to enable the double authentication and things like that, right? You need to connect to the other, like the third party component, and that part you actually need the solution architect or software architect to decide how things are connected together. Okay? Yeah. Another one, I'm no expert, but I guess architect engineer focus more on the macro level. Yes, you are correct. And software doing more day-to-day coding. Yes, correct. Okay. Day-to-day, I focus just as much on architecture within boundaries. For example, we have ECS cluster and things all set up. Yeah, that's right. Okay. Yeah. Okay, that's a rapid prototyping. In general, all right, there are three steps. First, you elicit the requirement, definitely. But once the requirement is there, you start design the prototype and then present to the client, let them review, and then you refine and iterate. So this will help you to get the feedback from the client as early as possible. And then it will mitigate the risk of the scope creep or project failure as much as possible. All right. Okay. Okay, I should take a break. Oh, what about we do some activities? Okay, let's go to the next question. Yep, everyone go to the poll EV. And yep, and start the first question. What is the primary goal of software engineering? Okay, here we go. We have 5 response. Okay, 1 minute left. Just answer this question quickly. Go to the pollev.com/fit5136. What is the primary goal of the software engineering? I expect 100% correct. Okay. Okay. Since we don't have much time, okay, let's move on. All right, let's lock the poll and then let's see the response together. All right. Okay, so the primary goal of the software engineering, majorities of the students got the answer correctly. The goal is to develop the software efficiently, reliably within the budget constraint. So that's the part here. What is that? Yeah, we want to develop the high quality software system that meet the needs at the lowest cost, right? That's the main goal of the software engineering. It's about economy, okay? It's not just about algorithm, okay? Yeah. All right, next. Yeah, next question. What is that? What is the waterfall model in software development? All right, go for it. Okay, roughly 50 students, 50 response so far. Okay, maybe I'll just lock the poll and then, yep, 3, 2, 1, no more. Okay, yep. Let's see the response. Yeah, I think the answer should be what? B, right? Linear and sequential approach. Okay, good. Yeah, roughly 70%, 69% of the students get it correct. Okay, maybe the first question. Let's review the answer, the choice here. Let's go through it together, right? First, waterfall is not iterative, okay? And it's not incremental as well. That's the more towards the agile, okay? It's not iterative at all. Whether the waterfall model is actually flexible or not is not really flexible, right? As I mentioned, when the requirement phase is done, then it's done. We cannot even go back, okay? And it's not, is it adaptive or not? No, right? The process itself does not really welcome the requirement change at all. Waterfall, it is a reactive and unplanned approach. No, it is like super plan driven. So it's the choice number 4 is not the right answer here. So the correct answer is choice B, okay? A linear sequential approach. If you look at the slide here, look at that. It is like super linear, super sequential, super plan driven, right? So that's the correct answer, okay? Yep. Okay. Next question. Okay, HI. Wait. Okay, wait. I haven't finished the HI yet. Okay, where are we? Incremental development. Okay, maybe I should finish the slide. Okay, yeah. So I think just a summary. We talk about the waterfall model. We talk about the rapid prototyping, and next I'm gonna talk about the incremental software development. Okay, so the incremental software development, they try to merge the specification, the requirement, the development, and the testing together into one activities. Looks like a milestone, looks like a sprint in Agile. Looks like. That's why they call incremental. So that means in short, the key concepts of the incremental here, it means that they want to incrementally deliver the versions of the software system over time. Okay, that's a key concept. All that. That means once they have the outline description, the high level the requirement, they already develop the spec, development, validate. Okay. Once they finish these concurrent activities, they deliver to the client as an initial version. Next one, intermediate version. Next one, the last one, the final version, and things like that. So that's why they call incremental software development. Okay. Incrementally deliver the software version to the clients to get the feedback as soon as possible. All right. The benefit is that the cost of accommodating the changes is actually reduced a lot because we welcome the changes, right, for each of the iteration increment here. And it is so easier to get the client feedback on the development work that has been done, okay? And it is more rapid delivery and deployment of useful software to the customer as quick as possible as well. Okay. However, there is a downside here as well. Okay. First, the process is not really visible to the clients. The managers need to regularly deliver, need regular deliverables to measure the progress. Okay. And if the system are developed too quick, and then it's not cost effective to produce the documents that reflect every versions of the software system as well. So I think this is a problem which is similar to the Agile as well. All right. And also the last point here, system structure tend to degrade over time when the new increments are added and things like that. So unless time and money is spent on the refactoring to improve the software, regular change tends to corrupt its structure as well. So that's a common process of common issues of the any incremental software development. All right. That's why, okay, now, the key highlight of the day. Okay. That's why Agile methodology is invented. So based on the incremental software development, Agile tends to appear in the late 1990 to reduce the delivery time for the working software system, right? And it is really suitable where client is not sure about what the spec is. Okay, yeah, I want to develop the startup. I want to build an app that makes lots of money about tourists. Okay, about tourism. Yeah, what should be the app? I don't know, right? So that's why Agile is really suitable for this context here. And the rapid development and delivery is very essential, right? Software must evolve quickly to reflect the changing business need. As I told you, business needs change every day, every month, every quarter. How can we adopt or welcome the changes as quick as possible? That's why we need to adopt the Agile methodology. And it is actually similar to the incremental software development, as I mentioned in the previous slide. All right. So basically, we start from the what is that? You define the scope, right? You decide the software system, develop demo, deliver to the customer, yes, no, and things like that. Okay. Yeah. So I will talk about more detail. I mean, the details of the Agile project management will be given in week 4, right? Okay. But no matter what, I think the key point about the Agile is really about the Agile manifesto, and everyone should know. Okay, so if you just Google, right, Agile manifesto, they talk about Agile manifesto. Oh, yeah. This is the same one that I actually copy and paste here, okay? The manifesto, they try to say that individuals and interactions over the processes and tools, okay? So they really, based on the agile software development, they highly value the individuals, the team, the human, the interactions, rather than the processes and the tools, okay? They don't care about the process. Working software over comprehensive documentation, okay? So that's why this is really the opposite of the waterfall software development process, where the solid, rigid software requirement is needed before before the team develop the software. However, in contrast, the agile software development, they focus on the working software first. Every iteration, every milestone, every sprint, where's the working software? Where's the prototype? We're gonna focus on that, okay? If nothing works, I don't see anything, then we consider there's no deliverables here, all right? Customer collaboration over contract negotiation, okay? This is so important. When you discuss with the customer, you really want to work closely with them and be part of their team, right? Try to listen more than you speak. Listen what is a problem, what is a requirement, and then you try to elicit the requirement as much as possible. This is a problem, this is a motivation. That's why we need to develop this piece of application, things like that, okay? You should be, responding to change over following a plan. So that's agile, right? Let's say today you plan like this, A, B, C, D. Tomorrow you got a new requirement. You need to respond to that requirement change as well. This is really part of the agile software development. All right, and this is the manifesto that is developed by these people. Okay, let's take a look at the video a little bit to describe what exactly is the Agile Manifesto.
So it was 2001, and a group of software visionaries gathered at a ski resort to share their experiences and figure out why so many software projects were failing. This wasn't just about documenting best practices. They knew the industry required a fundamental shift in values, and so the Agile Manifesto was born. A declaration of 4 bold value statements that became the basis of a new approach to software development and would change the industry forever. But what were those 4 values, and why should you care? Let's take a look. But first, it is important to point out that the Agile Manifesto ends by noting that all of the things mentioned are important, just that some things must be prioritized over others. Okay, here we go. Number 1, individuals and interactions over processes and tools. This doesn't mean throw processes and tools out the window. It simply means that a good face-to-face chat should trump rigid workflows and impersonal forms of communication. Number 2, working software over comprehensive documentation. Makes sense, right? But traditional software development often produced extensive documentation before a program was released for initial testing. Some documentation is good, but wouldn't it be better to have the program than a book describing it? Number 3, customer collaboration over contract negotiation. Sure, you'll want to start out with some initial guidelines, but instead of locking customers in a cage by defining the exact details of the project before it starts, teams and customers should collaborate, find the best solutions. And finally, number 4, responding to change over following a plan. Nothing ever goes entirely according to plan. So instead of sticking with something that isn't working, it's much more effective to make adjustments as your situation changes. Following the values isn't always easy, but when you build them into your team's processes, customers notice, and the payoff is huge. Which of the Agile values do you think is the most important?
Okay, thank you. So, Agile, right? Agile is really how can I say, it's not the process, okay? It's more like philosophy, the values, that kind of thing. That is more like high level things, okay? But to make sure that the process actually follow the agile methodology, right? So people have already defined 2 types of the agile framework, okay? So the first one is called Kanban. These are the 2 most popular agile framework that is used nowadays, okay? So Kanban, It is originally from Japan. Kanban, the goal of the Kanban is about to visualize the workflow, the flow of the card, the flow of the work item, and things like that. Okay. So if you look at the Kanban board here, as you can see, there will be a backlog to do ongoing and the done. Okay. So the Kanban board, right? Let's say if you think about like IT service desk, probably when someone create an IT service request that, okay, yeah, the printer doesn't work, the Wi-Fi module doesn't work, I cannot even connect to the Wi-Fi whatsoever. There are billions of issues here, no, not billion, I mean hundreds of issues every day, right? So it will be in the backlog. And then for every day, every morning, the team will discuss and try to identify what would be the tasks or to do things, okay? So they're gonna move the card from the backlog to the to-do. Once they already start working on it, they move to the ongoing. Once they finish, then they move the task to done. Okay. So the goal of the Kanban board is really about visualizing the flow for each of the work item, the status of the work item, whether it is in the backlog, it is in the to-do, ongoing, or the done, that kind of thing. Okay. That's the goal of the Kanban. Yeah. And the Scrum. Scrum is a framework that helps teams to work together to deliver, sustain complex products. Everything is divided into the time frames. So Scrum, we start from the vision. Okay, this is a high-level visions of the software product. We come up with or define the user story. As a user, I want this A, B, C, D. Then they start as a sprint. For each of the sprint, they prioritize what will be the backlog that they want to deliver for each of the sprint. Each of the sprint lasts between 2 to 4 weeks. It really depends. And for the team, every day they're gonna have like a daily stand-up meeting. Okay, 24 for every 24 hours daily stand-up meeting to make sure that everyone is on sync, everyone is on the same page, and the project is on track as well. Okay, this is a high-level explanations of the Kanban and the Scrum. Okay, any question so far? If not, okay, let's say I'm gonna say if not, okay. The last one, I think this is the last one. Yeah, and then we're gonna do the poll. So the last one, right? This is the last popular software development process, okay? It's called open source software development, okay? And examples of the products that use or adopt open source software development could be Mozilla Firefox, Android operating system in your mobile phone, okay? The Galaxy or the Linux open source operating system as well, okay? So I think the open source here, one possible scenario. So here, right? Think about the Linux. Let's say what happened is that there will be a team develop the initial version, they make it available on the GitHub or the whatsoever, and then they're gonna welcome lots of developers all over the world, okay, to contribute to that project, that kind of thing. So that's an examples of the open source software development, okay. So the key point here, individuals actually work voluntary on the open source software projects on their spare time rather than getting paid, that kind of thing, okay. And there's no standard lifecycle model at the moment, okay. It really depends on the software requirement, okay. So yeah, one comment from the student: the Linux kernel mailing list email patch scare me. Yes, that's right. So if you are part of the Linux open source software projects, you get this kind of email as well. Okay, let's jump to the poll everywhere, which is the fun part of the lecture. Yep. Everyone, go for it. What is the primary goal of agile software development? Yep. This is really just to check everyone whether you understand the concepts of the agile software development or not. There are a few choices here: to follow a strict plan, to focus on the documentations and processes, to prioritize customer collaboration over contract negotiation, to deliver a working software product quickly. Yeah. The key point here is that, yeah, the goal, you just follow the Agile manifesto. Okay. Yeah. Let's spend a few more seconds. And then we're gonna lock. Okay. And then let's see the response together. Okay. So primary goal, what is that? The answer. Right. Okay. So we got a mixed answer between choice C and choice D. Okay. But let's review one by one together. To follow a strict plan and schedule, right? Yeah. Agile is not really about the strict plan at all. That's more towards the waterfall model. Okay, so A clearly is not the right answer. If you the second one, to focus on the documentations and processes, this is actually violate the Agile manifesto, right? Documentations and processes. Yeah, we do not focus on the documentations and the processes at all. We focus on the individuals and interactions and the working software. All right. So the last two, okay, prioritize customer collaboration over contract negotiation. That's the one of the correct answer, definitely. What about to deliver a working software product quickly? Yeah, could be a correct answer, but I think it is closely related to the primary goal, okay, of the Agile software development. We also want to deliver the working software, okay, as well, right? Product quickly. So I would say the choice between C and D, I would say that both of them, they are correct, okay? I feel I should make it clear. Yeah. Okay. Next. All right. What is the main benefit of using Agile software development? All right, here we go. What is the main benefit? Nope. Sorry. What is the main benefits of using Agile software development? Looks like everyone is going to get 100% correct. Okay. Everyone just try to participate the quiz as much as possible, to be honest. There's no cost here. All right, okay, let's log the answer and see what would be the results. The goal of the quiz is to actually check whether you have a correct understanding or not, and then that's how I try to, explain why it is correct, why it is incorrect as immediately, within the lecture. Okay, respond. D-Dog, oh, definitely, clearly. The benefits of the Agile software development is about flexibility, adaptability. Whether it allows for a more predictable project timeline or not, I'm not really sure. Waterfall might be more predictable, right? Because you already define the process is very plan driven. That's why the timeline is quite predictable. But for the Agile, we deliver the working software incrementally every sprint, and we don't really know whether we're gonna, finish it. Okay, yeah. And then next, it encourage a fixed scope and the requirement. No, actually, Agile, we welcome for the requirement change. The fixed scope should be more towards the waterfall model. Okay. The third choice here, it focuses on the detailed documentations and the planning. Clearly, it violates the Agile manifesto. we actually focus on the working software over the comprehensive documentation, right? So we really don't focus on the detailed documentation and the planning at all. Okay, so the clear answer should be the choice, the fourth, the last one here. It promotes the flexibility and the adaptability. So one question in the Zoom chat, what is the sprint backlog, right? So sprint backlog is about the list of the things to do. That's it. This is a to-do list, but we will do it or not in this week, or we don't know. Okay, it's just the things that we need to do in the backlog. Whatever we are going to do this week, we're going to move the tasks or the work items from the backlog to the to-do. Okay, yeah, that's a shortest description that I can give to you. Okay, next. Yeah. Okay, all right. So what is the Agile Manifesto, everyone? What is the Agile Manifesto? Today we have only 10 questions, okay? We have gone halfway already. I know everyone is hungry for dinner, so just stay with me, all right? Yeah, what is the Agile Manifesto? Let's yeah, I'm gonna give you another 5 seconds. 5, 4, 3, 2, 1. All right, let's lock the poll and see the response. What is the Agile Manifesto? Clearly, it's not the detailed project plan. All right, it is a set of values and principles for the Agile software development. Clearly, B, choice B. It's not the software testing. It's not the project timeline. And 90%. Thank you, everyone. You are the best. Okay. Yeah, it's not the document outlining the project timeline. No, okay. Agile Manifesto, just want to emphasize again. If you Google, these are the manifesto, it's about the values or the principles for the software, for the Agile software development. All right. Thank you, everyone. Okay. Next question. Which of the following is not one of the Agile Manifesto values? All right. But try your best not to Google and look for the website, okay? Let's try to answer from your DNA, okay? Yeah, from whatever you remember. Yeah. First, individuals and interactions over processes and tools. Is that correct? Working software over comprehensive documentation, following a plan over responding to change, customer collaboration over contract negotiation. Which one is the right answer? Which one? 50. Okay, let's see the response. Definitely, D-Dog. Will I get 100%? No. Oh, which one is not? Sorry. I get confused myself. Okay. So clearly, not the choice D. Okay. That's actually it is, right? But what we ask is actually it's not. Yeah. Working software over comprehensive documentation. It is. Yeah. Individuals interactions over process system tool. It is. Yeah. So the question, which one is not? That means following a plan over responding to change. Okay. 64% got it right. Okay. But don't worry. I actually got confused as well. Okay. You are not alone. Even myself. All right. Next. Okay. 8. Okay. There we go. I think so we are at the end of the lecture, okay? So today we already talked about the software, the high level of the software engineering. We talked about the structures of the unit, what will be the assessment. I described about what exactly is a software engineering, different processes and things like that. However, we are in the age of the AI, right? I really want to ask everyone, all right? Why go back to question 6? No. Just want to ask everyone, have you ever used any AI coding tools? Okay, go for it. I need to click activate. Cannot answer. Okay. Okay. It's wrong. 1 second, 1 second. Yep. Oh, really? Okay. Yep. Okay. There we go. That's a software bug, right? Can someone send an email to poll everywhere? Ah, jeez. Okay. Wow, this is a yes no question, so everyone get the answer so quick. All right. Let's see the majority. This is really about exploring. I really want to understand about your background and whether you are using it nowadays or not. Okay. And the answer is, oh my goodness. Okay. 70% of the student using the AI coding tools. And would you mind type in the Zoom chat, okay? Like which tool that you are using at the moment. Yeah, I really want to know. Just type in the Zoom chat, okay? Yeah, this is about sharing to everyone as well. These are the common tools that students are using nowadays. Yep, so based on the answer, some use Perplexity, Cursor, Copilot, yeah, Claude Code in the CLI. Gemini CLI is actually very good as well. Yeah. No advertisement here. Okay. All right, good. Thank you. Okay. But before I finish my lecture, right? I really want to highlight. I found this figure on the internet on LinkedIn a few days ago. Looks like 70% of the students actually you can use AI coding tools, and you can just wipe it, right? Like, yeah, I want a website, generate something for me. But this figure actually distinguish between highlight the difference between the software produced by the AI vibe coding or the real engineer software system. Okay. So if you look at the house on the AI vibe coding, maybe you can have a house. Okay. You can live in it, but whether you can live it for 100 years or not, that's another story, right? On the other hand, if you have a well-engineered, well-crafted software system that are designed by human, it looks like super solid, very, robust, very sturdy. Whether we have like a how can I say earthquake or not, we can still survive. Okay, so I think this is a good example to highlight the difference between the AI vibe coding and the AI engineer software system, okay, that are engineered by the humans. So many of you may ask a question, hey, look, we have AI vibe coding tools nowadays. Do we still need software engineers or not? Surprisingly, okay, I'm gonna Google here, Anthropic software engineer, okay? If you go to the career, and this is the roles. This is an AI company, and whether they hire software engineer or not, right? Yes, right? And look at the salary. this is just a random click, okay? Some people say that they hire like for 500,000 annual salary. So it means that AI model is just AI, okay? But we still need software for people to access as well. So in short, my takeaway here is that despite the AI booming age, okay, software engineers still exist. Just the coding activities may be less important, okay? However, when we develop the software, we still need to elicit the requirement from the client anyway. So we still need human. We still need software engineers. And the rest of the lecture, we're going to talk about how should we elicit the requirement and focus on the activities that human is needed as part of the 2028 software engineers. Okay. All right. I'm going to close the lecture with another 2 more questions. All right. Everyone, don't leave it yet. Okay. Yeah. So how do you feel about the lecture today? All right. Yeah. Go for it, everyone. So your feedback is really important. And yeah. So yeah, that's right. If you like it, say like it. If you don't like it, let me know. What can I improve? And then I will try to adjust the lecture to follow your need as much as possible. Yeah. All right. And yep, let's see. And the next question as well. Yeah. What do you like about the lecture today? Yeah. Okay. Feel free to say it. Yeah. I would like to hear. If you like it, say like it. What do you like about it? What do you learn? And things like that. Yeah. Okay. But last thing, okay, of the day, I know everyone is hungry, okay, for the dinner. I just want to say thank you so much, everyone, for your attention, for attending my lecture. This is the first week. I can see like over 100 students attend. I hope that I can see or meet everyone until the end of the semester. And I'll try to make the lecture as most engaging as much as possible. And if you have any feedback or the suggestion, please feel free to let me know as well. Okay. All right. Have a good rest of the day and then see you next week. Okay. Bye-bye.